Hello everybody and welcome to our lesson on section 4B, Logarithms in Base A. And we're going to talk just very quickly, a little review of logarithms. So from page 110 of your text, remember that the exponential y equals 10 to the x, looks something like this, has an inverse that is reflected through the y equals x line that behaves in the inverse way. So the inverse of the function y equals 10 to the x is the same as y equals log x. Okay, remember that for an inverse function, all the x's and y's are interchanged. So every point that is on this original function has a mirror point in this function where the x and y are interchanged. And this is called the logarithm function. Okay, so if f of x equals 10 to the x, f inverse, this is not a derivative, this is an inverse of x, is log base 10 of x. And generally speaking, we don't write this 10. Okay, if there's no base written, then it's just log of x. There are logs of other bases, but 10 is a common one to use. What's new to you now is that we might have a log with a different base. So we already understand that log base 10 of x is the inverse of 10 to the x. Well, if we have a different base, like a to the x, then log base a of x is the inverse of this function. Okay, so just like a to the x would have certain common points, 0 and 1 is always on every exponential function, because when x is 0, this will always be 1. And 1 and a, when x is 1, y will always be equal to the base. The inverse function has the points 1, 0, and a1. The x's and y's are interchanged. Okay, and so we can say if b equals a to the x, then x is the logarithm in base a of b. So these two statements are interchangeable. B equals a to the x is the same as saying x equals log base a of b. And you can imagine that this is base to the exponent equals this value. Okay, and a couple of rules about logs, in particular the cancellation laws. If y equals a to the x, then x equals log base a of y. So what this means is if we have the base that we're taking the log of and that we're taking a value here with that base, those two values kind of cancel out and leave us with x. And likewise, if I have a base raised to the exponent log base a of x, these two a's kind of cancel out and leave us with x. So, for example, if I want to write an equivalent exponential equation for log base 10 of 10,000 equals 4, this is my base, this is my exponent, and this is the value. So 10 to the 4 equals 10,000. Here I can say 3 to the 1.5 equals root 27, or 3 to the 3/2 equals the square root of 27. If I want to write an equivalent logarithmic equation, so go backwards, I would say log base 4 of this value equals 3. It's saying 4 to the what? 4 to what exponent gives me 64? Likewise here, I could say log base 2 of negative 3. Log base 2 of 1/8 equals negative 3, meaning 2 to the negative 3 equals 1/8. And I can evaluate some logs in my head. So log base 2 of 128, that means 2 to the what gives me 128. That's what I'm thinking. And this is a little bit of trial and error right now. 2 to the 7 gives me 128. Or I could write log base 2 of 128 equals 7. Likewise, here I'm asking 2 to the what gives me the cube root of 2. Well, think about this as 2 to the 1/3. Then that's pretty easy to figure out that my exponent must be 1/3. And therefore, log base 2 of the third root of 2 is 1/3.